Hi, welcome to this lesson on algebra word problems. Solving a word problem, question 7. Kaylin plays a few games of bowling. In the first game, she scored 110 points less than the third game. So from the first game, 110 points less. She scored a total of 208 points from the first two games. In the third game, she scored 80 points more than the second game. What must she score if she wants to get an average of 146 points after playing a fourth game? Alright, so after reading the full question, we are interested in working out the score for the fourth game. Since all the games are referenced with each other, let us assign the variables of the scores as follows. The first game score, let's call this x sub 1, x1. For the second game score, let's call this x2. And similarly, for the third and the fourth games, we will call these x3 and x4. So let's break up the information we were given to create a system of equations. In the first game, she scored 110 points less than the third game. So the first game score is x1. That is equal to the third game score, but minus 110 points from that, because she scored 110 points less than the third game. This is equation 1. She scored a total of 208 points from the first two games. So if we add up the score for x1 and x2, we get 208 points. This is equation 2. In the third game, she scored 80 points more than the second game. So the third game score x3 is the second game score x2 plus 80 points on top of that. That is equation 3. Lastly, the average must be 146 points after playing a fourth game. So how do we work out average? We sum up the total game scores, so x1 plus x2 plus x3 plus x4, and we divide that by the total number of games, which is 4, and that must give us 146. This is equation 4. So these are our system of equations. Now from the system, we can see that x3 gets referenced the most relative to the other variables. So let's try and rewrite the other variables in terms of x3. Equation 1 does this nicely for us because it tells us what x1 is with respect to the variable x3. It's x3 minus 110. Equation 2, that's also fine for now. We'll leave it as it is because there are no x3 variables to reference here. Equation 3, we want to reference x2 in terms of x3. So I'm just going to rewrite equation 3 by subtracting 80 on both sides. So I'm going to get x2 equals x3 minus 80. So this is still equation 3, just written in a different form. But now it's in the form we like because x2 is being referenced in terms of x3. That's x3 minus 80. So if we add equation 1 with equation 3, why am I doing that? Well, the left-hand sides of the equations are x1 and x2. So let's write out equation 1. It's x1 equals x3 minus 110. And x in the third equation is x2 equals x3 minus 80. So if I add these two equations, so add the left-hand sides, I get x1 plus x2. And the right-hand sides, I have x3 minus 110 plus x3 minus 80. I can clean that up. I have two amounts of x3. So that's 2 times x3. And I have negative 110 plus a negative 80. So in total, I have negative 190. Let's call this equation equation 5. So if you look at equation 5, the left-hand side is x1 plus x2. And if you look at equation 2, the left-hand side is also x1 plus x2. So since the left-hand sides of equation 2 and 5 are both equal, I can equate their right-hand sides. So from equation 2 and equation 5, if the left-hand sides are equal, then the right-hand sides are equal. So the right-hand side of equation 5 was this guy here, 2x3 minus 190. And the right-hand side was 208 for equation 2. So in doing so, I've now successfully just have one variable in this linear equation, which I can now solve for. So I add 190 to both sides, giving me 2x3 equals, that'll give me 398. And dividing both sides by 2, I therefore have x3 must be, that'll give me 199. So I've figured out the third game's score. It is 199, sorry. So this is 199. All right, but now we can actually solve x4 very smartly by looking at equation 4, the only one we haven't used yet. So how do I do this? Well, remember from equation 4, you have that x1 plus x2 plus x3 plus x4 all over 4 must equal 146. But we know from equation 2 that x1 plus x2, the sum of the first two games, was 208. And would you look at that? In equation 4, you have x1 plus x2 up there. So this means that I replace that x1 plus x2 with 208 plus. But also, we just worked out the value of x3 from equations 2 and 5. So from equations 2 and 5, we worked out the value of x3 to be 199. And would you look at that? There's an x3 there. So I'm going to put that as 199. Plus x4, which is the variable we're looking for, the fourth score of the fourth game, divided by 4 equals 146. I can now solve this fractional equation, this algebraic fraction. I multiply both sides by 4 to get rid of that denominator of 4. Doing so, I have 208 plus 199 plus x4, and that's going to equal 4 times 146. Cleaning that up, we have 407. So 407 plus x4 equals 4 times 146, putting that in the calculator, and you'll get 584. So now I subtract both sides by 407, and I therefore get x4 equals 584 minus 407, and that gives me 177. Therefore, Caitlin would need to score on her fourth game 177 points to have a total average of 146 points amongst all 4 games. All right, if we put this in, we will see that the solution is correct. All right, I'll see you in the next one.